guys, welcome back to my YouTube channel. I'm Nahid, and in this video I'm gonna talk to you about one of the most vital and practical topics in the world of programming. Yes, it is clean code and its principles. So let's discover together its goals, practical applications, tools, and so on. Before we dive into the principles and concepts of clean code, it's better to get an overview of it so that we know what we are going to learn more about. For this purpose, let's check clean code definition as a first step. Clean code is a term from software development and addresses the clear, comprehensible, traceable, logical, and disciplined implementation of the code. The goal is to produce software effectively and efficiently, and also to design the code so that it is really changeable, readable, expandable, and maintainable. In today's software development practice, it's not uncommon for code not necessarily to be clean. This quickly leads to errors during adaptations or problems with extensions. For example, when a small change leads to a cascade of subsequent changes. And as a second step, let's have a look on clean code values. The approach to implementing clean code is based on the foundation of 4 different values: correctness, changeability, production efficiency, and continuous improvement. Now, let's check these values in a little bit more detail. The first mentioned value is changeability. For this purpose, I should say software lives, often even longer than originally assumed. It's improved, adapted, and extended. The easier can be adapted to changing requirements and conditions, the more changeable it is. This evolvability can be increased by using different design principles that influence the software architecture, such as the abstraction of information, the separation of responsibilities, the use of interfaces, and the coupling of components. Ideally, changeability is taken into account for the very beginning of software development because the later it comes into focus, the more complex, expensive, and difficult it becomes to adapt. The second value is correctness. Correctness as a value may sound ordinary and simple at first, but there is more behind it than just the correct execution of functions, the correct use of classes and methods, or the application of principles and practices of software development. Often developers do not even know the requirements of customers. They don't know any acceptance criteria. They don't know any framework conditions or the system context. Instead of trusting that a test department will find possible errors, developers should understand what customers actually want before implementation. The third value is product efficiency. This one, as a value, considers 2 aspects of software development. The first aspect is software development causes effort and costs. Code that is difficult to read, modify, extend, or maintain extends development time and is inefficient. The more extensive and the longer a software is developed, the more these problems become significant. Production efficiency means that a software can be developed for years because the emphasis is on clean code. The second aspect is production efficiency is a measure of the other values. On the one hand, for example, in order to avoid endlessly increasing the effort required to ensure the correctness of software, and on the other hand, some aspects like gold plating, where more is developed with a positive intention than was agreed with the client. And the last value that I mentioned is continuous improvement. This value does not address the improvement of the implementation as such, because this aspect is already part of the evolvability. The continuous improvement requires the developers to deal with their way of working. For example, the following questions could come into focus. What experiences were made with pair programming? What are the causes of code smells? How can the cooperation with the team and with customers be improved? And what are our learnings in code reviews? So, continuous improvement is a value that revolves around the reflection of the team. As a next step, we may ask ourselves that what we may achieve with clean code. So, in order to answer to this question, it's better to focus on three main achievements. The first one is focus on developer velocity and innovation. It means work with forward momentum rather than on technical debt, all while retaining your top development talent. The second one is minimize rework and maintenance. It means clear and consistent clean code standards can be seamlessly integrated into your development workflow for easy adopting by all. And the third one is reduce risks and support a more secure code base. It means proactively address hotspots and vulnerabilities before they become a problem. This leads to fewer security breaches and less downtime. Now it's time to check more details about clean code principles. For this purpose, I should say, even if clean code values provide orientation for developers, but they are too abstract for concrete implementation. That is why there are different clean code principles. Principles are guidelines for structuring software. They complement each other, and ideally, a maximum number of principles is always observed. If software is developed contrary to these principles, the effects will become apparent in the medium team at the latest, for example, through increasing costs for adjacents. Although there are so many different principles for clean code, but for now I want to talk to you about some of them. The first one is DRY, or don't repeat yourself. This principle aims at reducing the repetition of software patterns, replacing them with abstractions, or using data normalization to avoid redundancies. The second one is KISS, or keep it simple and stupid. This principle demands not to see or implement things too complicated, and always to look for or use the simplest solution to a problem. The third one is DEEP, or dependency inversion principle. This principle propagates that modules of higher levels do not depend on modules of lower levels. Modules depend on abstractions, and abstractions should not be dependent on details. The next one is SRP, or Single Responsibility Principle. This principle addresses the software design according to which module with its classes, functions, variables, and data structures should be responsible to only one actor. And the fifth principle that I want to mention here is LSP, or Liskov substitution principle. This principle states that interfaces have a high degree of cohesion and should therefore only contain elements that belong together. The aim is to make the coupling between components lean and clear. Now let's talk about the importance of code quality. Why clean code matters? Clean code is not a luxury, but a necessity in the world of software development. It leads to better readability, easier maintenance, improved collaboration, fewer bugs, and enhanced scalability. Prioritizing clean code is an investment in the success of your projects. So, remember, the next time you write code, it's not just for the computer. It's for your team, your future self, and the success of your success. Moreover, writing clean code promotes good coding habits and best practices, which can benefit developers and their future projects. It's time to dive deeply into some tips for using clean code. It means to find out how do values and principles come together. The first one is general tips. It means follow the conventions, reduce complexity as much as possible, leave the code better than you found it, and always look for the cause and not the symptom of a problem. The second one is design tips. It means keep configurable data at a high level. Use polymorphisms instead of if, else, or switch case. Use separate multi-threading code. Avoid overconfigurability and use dependency injection. The next one is tips for names. It means use descriptive, meaningful, searchable, and pronounceable names. Replace magic numbers with named constants and avoid encodings. Now it's time to check tips for comprehensibility. It means be consistent and implement similar things in the same way. Use explanatory variables. Encapsulate boundary conditions as they are often difficult to understand. Prefer dedicated value objects over primitive types. Avoid logical dependencies. For example, do not write methods that work correctly depending on something else in the same class. And number 5 in this list is tips on the structure of the source code. It means declare variables near their usage. Dependent and similar functions should be close together. Place functions in a downward direction and avoid horizontal alignment. Keep lines of code short and use white spaces to associate or disassociate aspects and use on indentations. The next one is tips for functions. It means keep functions small by doing just one thing. Use descriptive names and use as few arguments as possible, and also avoid side effects. And last one here is tips for commands. It means try to let the code speak for itself. Do not comment on your code. If you do comment, do it to explain the intention or to point out possible side effects. So now it's time to find clean code tips, principles, and values in the real world of software development. For this purpose, let's have a look on some practical examples. The first example is about following conventions. It means using a naming convention is a great way to get started. It keeps things clear and lets you know exactly what you are working with. A naming convention like this example basically means you decide you will call your variables by names that adhere to a certain set of rules. It can get hairy, and a lot of people don't always agree on which is best. So, to keep it simple, it can be something as simple as prefixing variable names with their data type. The second example is about indicating variable scope. The next thing, which follows nicely from using naming conventions, is using a convention to indicate variable scope. Again, there are no rules and everyone has their own way of doing it. As you can see in this common convention in the example, as long as it's consistent throughout all of your code, it will always be clear what can be used from where. The third example is about saving time and space. It means writing slightly more technical code doesn't mean it has to be less readable. Multiple lines of duplicate code are not only harder to read, but they also increase the chance for error. The great thing about programming is that you can express complex commands in tidy, reusable, and clever ways. As you can see in the top example, there is a duplicated code. While this might look okay and it is functional, it isn't clear why any of it is happening at all. You can repair it with a simple command that explains what this code does. And in the bottom example, you can see an approach that cleans everything up. As the next example, I should say, remember the power of I. As you can see here, when you have a code block with multiple loops one after the other, you need different iterator variables. There is always debate about what to use, and the answer is slightly subjective. But when they are one after another, it makes sense to declare your iterator outside of the loop and reuse it. It's not only better to look at, as it's always clear that I is your iterator variable, but it's also slightly more efficient. In the next example, I want to mention it's better to say what you mean. This is pretty straightforward, but it's probably the most common and maybe the easiest one to forget. Easily, the most frustrating thing for another developer looking at your code is seeing a variable with a misleading name, or worse, named with a single letter. As the next one, I should say avoid disinformation. Be careful about words that mean something specific. For example, do not refer to a grouping of accounts as account list unless its type is actually a list. The word has a specific meaning and it may lead to false conclusions. As you can see here, even if the type is a list, account is a simpler and better name. As the seventh example, and as I mentioned before, use searchable names. Avoid using magic numbers in your code. Opt for searchable, named constants. Do not use single letter names for constants since they can appear in many places and therefore are not easily searchable. This is much better because, for example, max class per student can be used in many places in the code. If we need to change it to 6, for example, in the future, we can just change the constant. The bad example creates question marks in the reader's mind, like, what is the importance of 7? As the next one, I want to say, do not use flag arguments. A flag argument is a Boolean argument that is passed to a function. Two different actions are taken depending on the value of this argument. For example, there is a function that is responsible for booking tickets to a concert, and there are two types of users, premium and regular, as you can see here. I should say flag arguments naturally contradict the principle of single responsibility. When you see them, you should consider dividing the function into two. As the last practical example here, I want to mention do not have side effects. Side effects are unintended consequences of your code. They may be changing the past parameters in case of passing by reference, or maybe changing a global variable. The key point is they promise to do another thing and you need to read the code carefully to notice the side effect. And also they can result in some nasty bugs. As you can see here inside this function, the function is checking the password, but when the password is valid, it's also initializing the session, which is a side effect. You can change the name of the function to something like check password and initialize session to make this effect explicit. But when you do that, you should notice that your function is actually doing two things and you should not initialize the session here. Okay, our journey in clean code is coming to an end, and it's good to have a look at the fact that in this journey we found the definition of clean code. We learned what are its principles and values, what is the importance of clean code, and also we learned how to use it in practice. But in addition to all these things, it's not bad to remember clean coding is not a skill. that can be acquired overnight. It's a habit that needs to be developed by keeping these principles in mind and applying them whenever you write code. So, in the end, I should say, don't worry. I will put some useful links in the description of this video and you can check and read them more. So, thank you for taking your time to watch this video and until the next video, goodbye!